everyone. I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about diagonalization of matrices. So, diagonalization is nothing but process of finding diagonal matrix for the given matrix, right? So, working rule for this diagonalization of matrices are: first we have to find characteristic equation. Next, we need to find eigenvalues and after that eigenvectors. Next, corresponding normalized matrix N. So, N is nothing but normalized matrix here. Because here we are going to find the diagonalization for the symmetric matrices. So, in symmetric matrices, we need to find the model matrix that it is as a normalized matrix. So, for example, vectors are given vector is x1, x2, x3 means the corresponding normalized matrix is value is equal to x1 divided by L and x2 divided by L, x3 divided by L. So here L is nothing but square root of x1 square plus x2 square plus x3 square. In this way, we find the normalized matrix x1 by L, x2 by L, x3 by L for the corresponding eigenvector. After that, we calculate N transpose. N transpose is nothing but after changing rows and column, we get the N transpose value. After that, we calculate corresponding AN value. Next, we have to calculate D diagonalized matrices N transpose into AN. Now, we are going to see one problem. Diagonalize the matrix 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Here we consider the given matrix as A. So A is equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 here. Next we are supposed to find find the characteristic equation. Already we know the concept how to find the characteristic equation. So the characteristic equation for 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here s1 is nothing but sum of main diagonal elements. So adding these diagonal values we get 18 here. S3 is nothing but sum of minus of main diagonal elements. So adding all the minor value we get 45 here. S3 is nothing but determinant of A, which value is equal to 0 here. Now the characteristic equation will become lambda cube minus 18 lambda square plus 45 lambda equal to 0. So if S3 is 0 means one of the eigenvalue must be 0. So next we are finding eigenvalues for this characteristic equation. So lambda is common for all the values. Taking lambda outside, it will become lambda square minus 18 lambda plus 45, which is equal to 0. So factorizing this quadratic equation, we get lambda minus 3 into lambda minus 15. We get corresponding eigenvalues of lambda equal to 0, 3, 15 here. Now we are finding corresponding eigenvectors. For finding eigenvector, we should solve the A minus lambda into x equal to 0 matrices. So A minus lambda is nothing but diagonal values are subtracted by lambda. We get the A minus lambda matrix. So in case 1, we consider lambda equal to 0 here. Putting lambda equal to 0, the system A will become 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 into x1, x2, x3, which is equal to 0. Multiplying these two matrices, we get 8x1 minus 6x2 plus 2x3 equal to 0, 6x1 plus 7x2 minus 4x3 equal to 0, 2x1 minus 4x2 plus 3x3 equal to 0. Here, the other three equations are different. So you can consider any two of this equation and solving using cross multiplication rule to get the corresponding eigenvector for the lambda equal to 0. So here we apply the cross multiplication rule. We get x1 equal to 1 to 2. Here we are solving equation 1 and 2. Next, we need to find the corresponding eigenvector for lambda equal to 3. So putting lambda equal to 3 in system, here we get this matrix. After that, multiplying these two matrices, we get the three equations. Here we are solving equation 5 and 6. We get the corresponding eigenvector is x2 equal to 2, 1 minus 2. After that, we need to find the corresponding eigenvector for lambda equal to 15. So, putting lambda equal to 15 in system A, we get the two matrices. So, multiplying this, we get the three equations. So, solving any two, that means 8 and 9, we get the corresponding eigenvector x3 equal to 2 minus 1, 2. So, this is symmetric matrix and also non-repeated eigenvalues here because 0, 3, 15 are non-repeated values. For that, we should check whether it is orthogonal or not. So, for checking orthogonality, we consider x1 transpose into x2. So, taking transpose of x1, 1 to 2 and x2 multiplying this 2, we get 0. Similarly, we find x1 transpose into x3 equal to 0, x2 transpose into x3 equal to 0. So, this condition satisfied. So, the given vectors are orthogonal, pairwise orthogonal. After that, we need to find the corresponding model matrix n. So, n is nothing but 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3, minus 2 by 3, 2 by 3, minus 2 by 3, 1 by 3 here. So, after finding normalized matrix, we are supposed to find n transpose, take interchanging rules and color we get transpose and transpose. After that, we need to find the a n value. So, a into n value. Multiplying these two matrices, we get a n value here 0 to 10, 0, 1 minus 10, 0 minus 2, 5. After that, we need to find diagonalization, that is nothing but n transpose a n. Here, this is n transpose value and this is a n value. Multiplying this, we get 1 by 3 into 0, 0, 0, 0, 9, 0, 0, 0, 45. So, each and every value divided by 3, we get the corresponding diagonalized matrix 0, 0, 0, 0, 3, 0, 0, 0, 15. Here the eigenvalues are nothing but the corresponding eigenvalues here. Thank you.